Hello everyone, this video is about binomial expansion, manipulation to 1 plus x to the power of n. So previously, if we have the form 1 plus x to the power of n, we can expand and find the first few terms. But what if it's not in that exact form? So if we have square roots or if we have 1 over rational, what should we do? Well, we can just express square root as to the power of 1 over 2, 1 over 1 plus x to the power of minus 1, 1 over square root minus 1 over 2, that's the power. And for inside the brackets, if we have something other than 1, we have to factor out the constant. So for example, if we have 2 instead of 1, we can pull out the 2, we have this, and of course this means that 2 is also to the power of minus 1. 2 to the power of minus 1 is 1 over 2. So in the simplest form we have this. And another example, we have 3 plus 1 over square root x to the power of 1 over 2. This means we have square root 3 because we pull out the 3 and then it's also to the power of 1 over 2. And we have inside the brackets 1 divided by 3 because we have to pull out the 3, and the power is 1 over 2, the n. So for example, we have 2 plus 1 plus over 1 plus x, we have 2 times the binomial expansion we use is for this 1 plus x to the power of minus 1 because it's in the denominator. So we can do the expansion only for the parts in green, so only for the first 4 terms. For example, here the x should be just x, so x, x, x. The n starts from minus 1, minus 1, minus 2, minus 1, minus 2, minus 3, and then we can simplify everything, and in the end we multiply everything by 2. So it's 2 times 1 minus x plus x squared minus x cubed, and so on. And therefore the final answer is we have to multiply everything by 2. 2 minus 2x plus 2x squared minus 2x cubed. Another example, now we have, I'm just going to write this as 4 plus x squared to the power of 1 over 2, which means we can pull out the 4. We have 4 times 1 plus x squared over 4, and they are all still to the power of 1 over 2, which is equal to 4 to the power of 1 over 2, 1 plus x squared over 4 to the power of 1 over 2. I'm using green for this last form, to the power of 1 over 2. This is the binomial expansion. We're gonna use the formula for this part only, and therefore we have the square root of 4 is 2, so 2 times everything here. The x is x squared over 4, so x squared over 4, x squared over 4, x squared over 4. The n starts from 1/2 minus 1 minus 1/2, 1/2 minus 1/2, minus 1 again, minus 3 halves. and then we simplify. This is equal to 1 plus 1 over 8x squared minus 1 over 8 times 1 over 16. 8 times 16, 80, 48, 128 x to the power of 4 plus, we can cancel out the 3 here, so we have 2 to the power of 4, 16, 4 to the power of 3, that's 64, 64 times 16, 128, 256, 512, 10, 24. So plus 1 over 10, 24 x to the power of 6. And after multiplying by 2, we get 2 plus 1/4 x squared minus 1 over 64 x to the power of 4 plus 1 over 512 x to the power of 6. Last example. Here we have x plus 1 times, we're going to write this as 1 plus x squared to the power of minus 1. So this means we have x plus 1 times, we use the binomial expansion for the green part, so the x is x squared, x squared, x squared, the n minus 1, minus 1, minus 2, minus 1, minus 2, minus 3, and we simplify the first few terms, we get x plus 1, 1 minus x squared plus x to the power of 4 minus x to the power of 6. And if we're looking for the x term or the constant term or whatever, we just can multiply certain terms only, but since we don't have the actual question, let's just multiply everything. So we multiply by 1, we get 1 minus x squared plus x to the power of 4 minus x to the power of 6. Multiply by x, we get here we have x minus x to the power of 3 plus x to the power of 5 minus x to the power of 7. So in the end we get 1 plus x minus x squared minus x cubed plus x to the power of 4 plus x to the power of 5 minus x to the power of 6 minus x to the power of 7, and so on. Alright, that's it. I'll see you again next time.